Would it be surprising to find a rocky planet that dates back to the very early universe? It should be. The early universe lacked the heavier elements necessary to form rocky planets, but astronomers have found one right here in the Milky Way. Today we will discuss with you about some of the oldest stars that had rocky planets. Welcome back to Signature's Life, and you're watching Signature's Science. After the Big Bang, the universe consisted of nothing but light elements like hydrogen and helium with a little lithium. Rocky planets require heavy elements like carbon, oxygen, and iron, which astronomers call metals. Those heavier elements can only be found in the hearts of stars, and the first stars didn't form until about 200 million years after the Big Bang. Any extremely ancient planets formed not long after the universe began should be gaseous, not rocky. There wasn't enough time for stars to seed the universe with heavy elements for rocky planets, or was there? The planet in question orbits the stars known as TOI 561. TOI stands for Test Object of Interest, meaning it was spotted with NASA's TESS, otherwise Transiting Exoplanet Survey satellite. TOI 561 is one of the oldest stars in the Milky Way, about 10 billion years old. The rocky planet orbiting TOI 561 is one of the oldest rocky planets yet discovered. Its existence shows that the universe has been forming rocky planets almost since its inception 14 billion years ago. TESS found the planet, and a team of researchers used follow-up observations with the Keck telescope to learn more about it. They presented their findings at the January 2021 meeting of the American Astronomical Society. They also published their findings in a paper titled The TESS-Keck Survey 2. TOI 561 is in rare company. It's one of the stars in what's called the galactic thick disk. The galactic thick disk is composed almost entirely of ancient stars, whose chemistry and motion are different from the thin disk. Thick disk stars, including TOI 561, have much lower metallicity than stars in the thin disk, so finding a rocky planet orbiting it is surprising. The planet, named TOI 561b, was discovered when it transited in front of its star. As its name says, TESS is designed to detect the dip in starlight when a planet transits in front of a star in its field of view. Astronomers can gauge the planet's size by measuring the drop in light, and in this case, it indicates that the planet is about 1.5 Earth radii. Scientists use the Keck Observatory for follow-up observations. The Keck has a special instrument called the High Resolution Achilles Spectrometer, otherwise the HIRES, to confirm the planet's detection. HIRES allows astronomers to measure the wobble in the star caused by the planet's gravitational tug. That measurement reveals the planet's mass. In this case, the mass is large enough, 3 times greater than the Earth's, that TOI 561b has to be a dense rocky planet rather than a gaseous one. There are 2 other planets orbiting TOI 561, but they are both gas planets. The origin of the old stars in the galactic thick disk is unclear. They could be the remnants of an ancient galaxy that was swallowed up by the Milky Way, or they could be the first stars to form in the Milky Way, or it could be something else. Nobody is certain. As a planet orbiting an ancient 10 billion year old star, it's been through a lot. The wandering motion of stars and disks sometimes takes them above the galactic plane. An observer on TOI 561b would have been gifted some stunning views of the Milky Way's beautiful spiral structure. But there were likely no observers, not now anyway. Though the long history of the planet is unknown, it's too hot for life in the present day. TOI 561b is an ultra-short period planet. It orbits TOI 561 twice each Earth day at a distance that keeps the surface at about 2000 degrees Kelvin, otherwise 1721 Celsius, otherwise 3140 Fahrenheit. So, while it's a rocky planet, that rock is likely magma on the surface. What does this discovery mean? Well, it would be surprising if it was the only one. It's likely an indication that there is a whole population of ancient rocky planets orbiting ancient stars. In fact, TOI 561b isn't the first planet detected around a galactic thick disk star. The Kepler mission found 5 sub-Earth-sized planets orbiting the triple star system, Kepler-444. Kepler-444 is estimated to be just over 11 billion years old, and its 5 planets are all rocky planets smaller than Venus. They are also very close to their star and are blisteringly hot. There is also LHS 1815b. It's orbiting an M-dwarf star on the thick disk and was discovered in early 2020. It's a rocky super-Earth and has a blistering surface temperature due to its proximity to its star. There's still some mystery in the discovery, not so much over the planet itself, but the thick disk. There is disagreement and uncertainty on the nature of the galactic thick disk itself. Some astronomers think it doesn't even exist as a distinct structure. In 2012, some astronomers argued that the Milky Way has no distinct thick disk and said that their data showed that the Milky Way has a continuous and monotonic distribution of disk thicknesses. There is no thick disk sensibly characterized as a distinct component. Nobody is denying the existence of the ancient stars themselves or the ancient rock planets orbiting them. But what the existence of those planets means for our understanding of the universe is not clear yet.